Alright, so the Lucky Lovers discount average is 583 and a standard deviation of 862. We already knew that. That was the first problem. But now we have a new restaurant, a competing restaurant. They have a Lottery of Love promotion, and there a couple can select a specially prepared chocolate from a large bowl and unwrap it to learn the size of their discount. This restaurant's manager says the discounts vary with an average of 10 and a standard deviation of 15. So we don't have to calculate their average and standard deviation. We're being told those values. How much more can you expect to save with the Lottery of Love promotion? So now you got to be sure you read this question and understand what it's asking you. How much more can you expect to save with the Lottery of Love promotion? So if I want to know how much more something is, that means I need to subtract. Some of y'all miss out on that concept, and you need to work on kind of learning these words, how much more. That's cluing you in that you need to subtract. So we're going to subtract Lottery of Love minus the Lucky Lovers. Now, I called Lucky Lovers D for discount earlier. I'd like to use a different letter for Lottery of Love. Since they're all L's and discounts, it's hard. But I'm going to go ahead with B because they use a bowl. So I'm going to call this one B, okay? Just for no good reason. We could call them X and Y if we wanted to. So on average, how much more can you expect, that's an expected value or the average, of the difference in these two discounts? This is our Lottery of Love, and this is our Lucky Lovers. So how much more on average can we expect? So now we're using our formulas, and we can just simply subtract the means. The means are easy. If you want to do the mean of a sum or difference of two random variables, you just subtract their means or add their means. That's the easy part. So the mean of Lottery of Love was $10, and the mean of Lucky Lovers was $5.83. And I get a difference of $4.17. So I'm just doing the $10 mean minus the $5.83 mean and getting a difference of $4.17. So I can expect to save $4 more at the second restaurant, the Lottery of Love. What if they want to know, well, what's the standard deviation of the difference? What's the standard deviation of the difference? Now, this is where it gets a little counterintuitive. This problem makes sense. You just subtract their means. A lot of you would just subtract their standard deviations. That is incorrect. In fact, you don't even add their standard deviations. Remember, you can't combine STDs. You cannot add or subtract standard deviations. Instead, we always add variances. So I can do the standard deviation of the second discount squared plus the standard deviation of the first discount squared and take the square root. We can add variances and then square root them to get standard deviations. Even when I am subtracting the two events, I still add variances. And the reason why is because we add instead of subtract is because we've got a random event here and a random event here. So this has some level of uncertainty and this has some level of uncertainty. It doesn't matter if I'm subtracting them. If you add standard deviations, that means you are getting more uncertain. If you subtract standard deviations, you're getting less uncertain. Well, if I have two random events and I'm subtracting them, I'm not going to be less uncertain. I'm going to be more uncertain of those outcomes because I don't know what they really were in the first place. So I go to my calculator. You can even tell it looks like the Pythagorean theorem. In fact, if I just had this problem written on a piece of paper before this video, you probably would have thought I was doing the Pythagorean theorem. And you probably thought these were side lengths of a triangle. But it's the same concept. And so this is the mean, and this is the standard deviation of the difference. Be careful. I mentioned this earlier. This is why I wrote D1 plus D2 here. In general, x plus x plus x does not equal 3x like it did in algebra. These x's represent random events. Being random, they can take on different values each time they're evaluated. So what you really mean is x1 plus x2 plus x3. The reason why x plus x can be 3x in algebra is because x represents the same number. Like 5 plus 5 plus 5 is 15, which is the same thing as just 3 times 5. But for random events, this first X, if we think of the lucky lovers, this one could have been 0, this one could have been 10, and this one could have been 0 again, potentially. So when we add those up, we get 10. We don't get 3 times any one of these individual. 3 times this would be 0, 3 times this would be 30, 3 times this would be 0. So it's not 3x. It's x1 plus x2 plus x3.